Hi everybody. I'm trying to put together these videos as a helpful thing because I know that even though you started out doing organic nomenclature in high school and then you continue doing a bit of it at the end of first year, that it's often a sticking point for you. Organic nomenclature is really not as bad as you think. It's also not good. Nobody really loves doing it who isn't really old and probably German. But it can be broken down quite easily to just 4 steps. The first step, which is the most important, but there are times that you don't do it, is to find the functional group. Now, molecules often have more than one functional group, so we have to have a process to choose the one that we're going to base the name on. Our second step is to then find the parent hydrocarbon, which is defined as the longest continuous carbon chain containing that functional group that you identified as the highest priority one. Your third step, which is often the longest, is to find and fully indicate the substituents. The substituents are basically everything that you haven't covered with the functional group and the parent hydrocarbon. The final step, which is often not terribly hard, and which you have done in the past, is to indicate all the stereochemistry in the molecule. There are molecules that don't have any stereochemistry. You even have molecules where you only end up doing steps 2 and 3 in this particular game, or even just step 2. But let's run on and do, instead of going into each of these steps in detail right now, I just want to run through a given molecule. And the one that I'm going to write down here is one that I just invented on the fly, but it's an amino acid, not one of the natural ones. And it has the ability to do all 4 of these steps on it to get the name figured out. Okay, here we have our amino acid. It has, if you take a peek at it, 3 things that if you were talking about doing chemistry in this molecule that are functional groups. There's a carboxylic acid, there is an amine functionality, a primary amine, and there's an alcohol. We're not going to go into the list yet of who gets priority over who based on what rules, but there is an official list that lets you choose between the 3 to see which one wins. Our 3 groups here, the amino group, the carboxylic acid, and the alcohol, can be compared with this list to see who is higher on the list than the other 2 are. And in this case, the thing that is on the top of the list would be the carboxylic acid. So this molecule, when we get to step 1, which is to pick a functional group, that functional group is going to be the carboxylic acid. That makes the amino group and the alcohol group going to be part of step 3, which is the substituents. We are at step 1, the functional group. We have already decided that our crowned victor of this particular competition, look out, my battery's low, is going to be that carboxylic acid. When you have a carboxylic acid, the way that we indicate that that is the functional group is we suffix the name with oic acid. So kind of like carboxylic acid, but OIC acid. That gives us the answer to question number 1 of 4. Once that has been determined, the parent hydrocarbon will be the longest continuous chain that contains the carboxylic acid. In this case, and in almost all cases, there are exceptions, that the carbon of that carboxylic acid will be carbon number 1 of our parent hydrocarbon. That's because it's terminal. It's at the end of a chain always, because the functional group itself has 3 bonds to create the functional group. You only have the 1 bond left to attach a parent hydrocarbon to. There are other functional groups that are in the middle of chains, and they get handled slightly differently. But the parent hydrocarbon is the longest continuous carbon chain containing that functional group. So in that case, we would start with carbon number 1 being at the carboxylic acid. So I changed my pen to a new color here. Carbon number 2 being right next to it, and as we keep walking on, that is 1, 2, 3, 4, 5 carbons, making it a pentane chain, or, as we now know, a pentanoic acid. So we've done the first 2 steps of 4. That's pretty quick and easy for a molecule of some reasonable complexity like this. Step 3 is everything that we haven't indicated so far. Every atom that we haven't included in our parent hydrocarbon and our functional group gets talked about in step number 3. And in here, the only things that we haven't described already are our amino group. Our amino group is on carbon number 2, and our alcohol. And our alcohol is on carbon number 5. Now, we give things different, slightly names when they're substituents than when they are the functional group of the molecule. So that would be a 2-amino 5-hydroxy is our substituent name. So we put substituent names in alphabetical order, though I don't actually truly care that you know that. Our last step, we have one stereocenter in this molecule, or one place of stereochemical interest, because remember that pi bonds can be E and Z, as well as stereocenters being R and S. But we don't have any carbon-carbon pi bonds here. The only thing we got going for us is that one center, and it is S. We'll go through the process of determining that as a reminder in a separate video. When we add all that together, we end up with the full IUPAC acceptable name for this molecule. It'll start with the stereochemistry, which is S, then 2-amino 5-hydroxy because A comes before H. Then, with no space or anything, jump right into the pentanoic because it's an alkane, not an alkene or an alkyne. And then oic acid indicates our functional group. So S, 2-amino 5-hydroxy pentanoic acid is the full name of our compound, and we're good to go. This method works for everything. You can name any organic molecule using these 4 steps, though I will grant you at some point it gets more complex than it's worth and we just give it a common name. But this is our full process. Step 1, giving the functional group. Step 2, the pentane, being the parent hydrocarbon. Step 3, the 2-amino 5-hydroxy, is our list of substituents, their positions and information. And step 4, finally, stereochemistry, gives us S. Our next video, we'll spend a little bit of time on parent hydrocarbons, on functional groups and their priorities and how to pick one and how to incorporate them into names, because some of them are obvious and some of them are a little bit less so, like for example, esters are a little harder to name. And we will move on from there to the other 2 steps after that one. All right, take care till then.